Hi there, welcome to part 2 of Algebra. In this part we'll be focusing on indices. We'll look at various questions from past papers that are going to prepare you for what you'll be expecting in your exam. I'll go through these questions right from the basics of indices, explain important concepts until we're comfortable with handling quite involving questions. An index is simply a power. For example, here we have been asked to evaluate negative 3 to the power 2. The 2 is the power. In the first question here, we're just being asked to see if we know what an index means. When we have 3 to the power 2, it simply means 3 multiplied by 3. You should have two 3's that are multiplied together. If we are given 3 to the power 4, it means we have 4 3's that are multiplied together. This is our first 3, second, third, fourth. With that said and done, we can handle this simple question that we have. When calculating for this question, since it's our first, I'll show all my working. I'll even show the powers there, giving us this as our answer. 0 is the required solution. The next question here has a different type of power. It has a power which is a fraction. When you have a power that is a fraction, I want you to remember this. P raised to m over n. You can see that a base, the bottom number, m over n being our power. What this means is you get the number at the bottom. I like to think of it as the number at the bottom represents what's at the bottom of a tree or a plant. If you have a plant, it will be in the soil. Under the soil here, you're going to have roots. So the number at the bottom of a fraction, you can see this soil here is representing our division sign. The top part is representing our top. So we have the m, the soil, and the n here. Very easy way to remember. The n is going to be the root. So n is going to be the number we'll put on the symbol for root here. And then the m here is going to be still a power. So whenever you have a fraction, always remember this simple conversion. The fraction of power is going to mean this representation where we have some roots. I will not say this is a square root symbol because a square root is a special type of root. A square root has no number here, which is something we just take as mathematicians for everyone to know that there's a 2 here. You don't put a 2 for a square root. So when you see this root symbol without a number, always remember that the n there is a 2. With that said and done, let's continue our question. We have 9 to the power half plus 1. What this simply means is it's the second root of 9 to the power 1. Most of the time we won't write it. In most cases it will just be written like this. This is the common representation. So now, what is the square root of 9? Or what is the second root of 9? The second root of 9 simply means what two numbers can you multiply by each other such that we have 9. If you know your multiplication tables, you know that 3 times 3 gives us 9. So we should have a 3 plus a 1 here, which is very simple to answer. The answer that we're requiring here is 4. The next question becomes even more interesting. We have a 5 to the power 2 in the denominator. There are two ways in which we can answer this question, and I'll share those two ways with you. The first way is we can write this question of ours in a new form. We multiply the 5 to the power 3 multiplied by 1 over 5 to the power 2. We consider that we have a 1 in the denominator, so that when we multiply, we get to 5 to the power 3 divided by 5 to the power 2. Then we can convert this to 5 to the power 3 divided by 5 to the power 2. And now we can use the property for indices when we have division. When you have division, and a key thing to notice is that the bases for your divided indices here, numbers with indices, or numbers raised to some power, should have the same number. We have a 5 here and a 5 here as our base. So we can continue and make a common 5 base, then subtract, which will lead us to 5 to the power 1, which is just 5. Alternatively, what can you do? The other thing you could do is use another property for these indices. Since we have 1 over 5 to the power 2, we can remember that it can be written as 5 to the power negative 2. So what you can take from this is, when we put a negative on a power, it means the base can be considered also as 1 over the number of the base. So 5 to the power negative 2 is the same as 1 over our base here, 5, and then we get the power, write it like that. This is a very important property. If we have just a number here, this is how we treat it. You later see how it changes if we have a fraction as our base. But always remember this property. If we have a negative, we can say 1 over our base raised to the power without a negative. So with that information, we can continue and say 5 to the power 3 plus a negative 2. Remember, in a multiplication has the impact of adding the powers, and I've put it here so that you don't confuse it with our earlier proposed way of solving. From here you can see we get to the same step of 5 to the power 3 minus 2. Then we get the same properties you used to solve a particular question on indices. The main goal is, if you know your properties very right, you can get the answer for any question correct. The next question here is having a base that is a fraction. Apart from that, the power actually for this question is also a fraction. Now, I want you to see how we deal with this question. What we do is first get rid of this negative here by swapping So first we swap this, and then we can remove the negative in the power. How is this possible? I'll explain. If we use the earlier property that we knew, the first thing that we need to do is remember a property which states that if we have a power like this and a fraction like this, the power is going to be distributed in the numerator and the denominator. So we'll start with 64 negative 1 over 3 like that. That's our power. Then we'll have 125 negative 1 over 3. What mathematicians found is we can quickly move from here to here by what you will see. If we rewrite this, it's the same as 64 to the power negative 1 over 3 divided by 125 like that. This division can be changed to a multiplication if we make this 1 over what we have. But before we do that, let's treat this negative like we saw for the 1 over 5 to the power 2. We can treat this by saying we have 1 over 64 to the power 1 over 3 divided by 1 over 125 to the power 1 over 3. Then we can work with that division sign. What we have is 1 over 3 multiplied by 1 over 125 to the power 1 over 3 over 1. And now if you look, instead of you going through this whole procedure, you can always just remember, if you have a negative power and you have a fraction, just swap the fraction and get rid of the negative. This will get some of your time in the exam. So when you have a negative power and a fraction of base, just swap the numerator and the denominator of your base and then get rid of the minus sign. You can see if we simplify this, we come back to this. Next, what we have to do now is distribute. This 1 over 3 can be put to the numerator and the denominator just like we did here. 125 to the power 1 over 3 over 64 to the power 1 over 3. And now we know what a fractional power means. Just means the number in the denominator is going to be our root. So we'll have 3, this root symbol, 125 like that, a 3 for the root symbol, and 64. So our goal now is finding the third root of these numbers. What is the third root of 125, and the third root of 64? Well, the best thing I can tell you is try out these numbers. You try 1 times 1 times 1, it gives us 1 still. You try 2 times 2, you will see that these numbers are not very difficult to get. 4 times 4 times 4 is going to give you 64, and 5 times 5 times 5 is going to give you 125. With more practice in mathematics, you get to know your square roots, your third roots. It's rare that you have your fourth roots, but these numbers are going to be very helpful. Next, we write our final answer. Our final answer is equal to 5 over 4. You could write this as a decimal number, 1.25, or as a mixed fraction. All of these answers must be marked. Due to time, most of the times the easiest is just this mixed fraction, this improper fraction, or the proper fraction. We've covered most of algebra. Now let's begin solving some equations. These equations are simple and they'll be using the information that we know. We have a fraction of power. How do we treat this type of equation? I want you to remember the process that we use. For example, when we have 2x equal to 4. To solve this equation, we divide both sides by 2. And then our answer is going to be 2. The similar approach will be done for fractional indices. However, the only difference is what we do to the index will remain just for the index. Here we divided the coefficients by 2, and so even the coefficients on the right hand side were divided by 2. If you have forgotten what coefficients are, let me just give you a simple recap. This number here is what we call the coefficient. This number here is what we call our power or our index, the main focus of this video, and this here is what we call our variable. In algebra, the property is simple. If I divide the coefficients by a certain number on my left side, I should also divide what is on my right hand by the same coefficient. If I multiply the variables on my left side by a certain variable, or a certain number, I should also multiply the variables on the right hand side. If I multiply the power on my left hand side by a certain number, then I also need to multiply the power for each thing on my right hand side by the same power. Of course, there will be some tricky scenarios when you are doing this, but when we're doing the basics of algebra, most of the scenarios are very easy to deal with. Let's utilize that information. This is our starting question. When deciding what number to multiply the powers on the left hand side and the right hand side, our guide is this. We get the actual power and then think in our mind, what number can we multiply this power such that we have a 1? If you think it's not very difficult, what you just have to do is find the multiplicative inverse of the actual power in the question. In this case, our multiplicative inverse is 3. You just swap the numerator and the denominator here. So what we're working with here is multiplying by 3 on our left hand side and then multiplying by 3 even on our right hand side. This leaves us with x equal to 9 to the power 3, and your job is just finding 9 times 9 times 9. 9 times 9 is 81, and 81 times 9 is not so difficult. 9 times 1 is 9, 9 times 8 or 8 times 9 is 72, and that's our final answer. Whenever you're doing any number multiplied by 9, a simple trick you can use is just subtract from the 9 times 10 of that number. For example, 9 times 9 is an easy answer. From 90, which is 9 times 10, I just subtract 9. So 90 times 90 minus 9 gives me 81. Remember, this is paper 1. You should be prepared to do these things very quickly. The same thing here happens when I'm doing 81 times 9. I can think of 81 times 10 and then subtract an 81. So I'm always subtracting the number that I start with here. Away from that, let's look at another question. The next question here is just a bit more involving. We have a coefficient of 4, which is equal to 9. Not a difficult question to carry out. The first thing is we need to get rid of the coefficient. So we divide both sides by 4. Hence we have x to the power 2 is equal to 9 over 4. Then we find a way of making the coefficient on the left hand side 1. That can be gotten by thinking of a number you can multiply 2 by to have 1, which is 1 over 2. 1 over 2 is the multiplicative inverse of 2. So you have 2 over 1 and then flip the numerator and denominator, giving you 1 over 2. With that said and done, we can easily see that when we multiply this by half, it will give us 1. I'll show that so that no one is lost. And then on our right hand side, we need to make sure we put some brackets like this, and then we continue. This is also using the information we are just from learning. You know that 3 times 3 is going to give you 9, and you also know that 2 times 2 is going to give you 4. So our required answer here is 3 here and a 2 at the bottom. Let's do just one question for more practice. Here we have 2x to the power 3 is equal to 16. just like we did, we divide both sides by 2, giving us x to the power 3, which is equal to 8. And then we think to ourselves, 3 multiplied by what number is going to give me 1 over 3, or simply the multiplicative inverse of 3. Next, we multiply the power on both sides. Then we have x equal to the root of 3, the third root of 8, like that. And we ask ourselves, what number can multiply itself by 3 times? You can see the number we're looking for is 2. So our solution for this problem is 2. Meaning, if where we had our x in this question, we put a 2. If we say 2 multiplied by 2 to the power 3, our answer is supposed to be 16. You should always perform this check. Sometimes you might make very simple mistakes that might cost you in the exam. After you're done with your paper, you can test the value of x in the equation that you are given and test to see if it really gives you the required solution. Indices get more interesting actually. Here we now have x as our power and we're asked to find it. How do we do it? One thing I'll tell you for free is that whenever you encounter such questions where the power has x in it, the first thing you need to do is make sure all your numbers in the question have the same base. In this question, it's very much simple, but you will see how in other questions you need to do a little bit of thinking. Here we have both our numbers on our right and left having a base of 2. So it's not a very difficult question. Of course, it's a starter, it shouldn't be too difficult. Since we've seen that both numbers here have the same base, next we should express these bases with a power. For example, this square root 2 is going to be written as 2 to the power half, so that it can match what we have on our right hand side. So after your bases are the same in the equation, make sure that all the roots are converted to powers. Next, you can see that it's very easy to solve for this question now. Since we have a base on the left hand side that is equal to the base on the right hand side, we can confidently say that our powers here can be equated. So x is going to be equal to half. We have another interesting question here. We've been asked to solve the equation, meaning we need to find the value of x. Just like I said, the first thing is making sure both the left hand side and the right hand side have the same base. Now, you might think to yourself, okay, since I have 25 this side, on my right hand side, I'm going to put 25 as a base also on my left hand side. But most of the cases, you won't have to do that. You need to think more general. If you were to use 25 as your base, there's no way you could multiply 25 by itself to get 125. Rather, you can see the relationship. 5 times 5 gives me 25. And then again, 5 times 5 times 5 gives me 125. So the perfect base to pick in this question is 5, because you can express 25 with a base of 5 or 5 to the power something. So what I mean is this 25 can be expressed as 5 to the power 2, and this 125 can be expressed as 5 to the power 3. In this case, the question will now be solvable. So with that said, we have 5 to the power 3. Now notice that the x here is multiplied by the power of the 125, so we include some brackets like this, and then write our right hand part, which is 5 to the power 2. Next, what we have to do is make sure this right hand part is expressed in a very similar way to our left hand side. Additionally, since this x is the power after the brackets, we can simply just multiply it by the 3 to have 5 to the power 3x, then equate it to 5. Then remember, we had a 1 over 5 to the power 2, right? We could write it like this. So we do the same thing we did earlier, and now you can see that the left hand side is 5 to the power something and the right hand side is 5 to the power something. Next, we can just equate our powers or indices. 3x is going to be equal to -2, and hence x is supposed to be -2 over 3. What has happened here? I have divided both sides by 3. (3x over 3), and they cancel out. We have yet another interesting question which asks us to find the value of x, which x is in our index or our power. Now, for this question, the first thing again, like I said, is finding a way of expressing the bases in a common number. We can't use 8 as our base because 8 multiplied by 8 gives us 64 and not 16. So we think again, 8 is not working. The base is start from 1. You go to 2. If you think there's a way of getting 8 using 2. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. Which means 2 to the power 3 can mean 8. Next, you also think, how can I get 16? Well, if we had 8 when we multiplied 3 2's by themselves, if we just multiply by another 2, we're going to have a 16. So, this question of ours can be rewritten as 2 to the power 3 to mean 8, and then here we'll have x minus 1. On the right hand side, we'll have 2 to the power 4. Now, the trick here for this question is how you deal with this multiplication. Most people might just say 3x minus 1, but that's not how it works. Remember, we started from the basics of algebra. If we have a 3 being multiplied by x minus 1, how did we do it? We expanded in the right way, right? Not so. So, the right way to do this is multiply the 3 by the x and the 3 by the -1, so that we have 3x minus 3. After we do that, we'll simply write our left hand part like this and continue with our right hand part. Now, this right hand part is simple, but the left hand part can be dealt with a little bit. Let me show you how we can do it. There are two ways. What you could do is you would say you have 3x divided by 2 to the power 3 equals to 2 to the power 4. This left hand part is the same as what we have here. Remember, when we have a subtraction, it simply means division, not so. So once we have this, we solve the question a bit quicker. Then we have 2 to the 3x. The division there simply means we have 2 like that in the denominator, and then we have 2 to the power 4. Then you can multiply this 2 to the power 3 by the 2 to the power 4. Now, this method here I've shared with you is not the most common way people do it. I've just shown you so that you can know that this method can also give you the right answer. I'll show you another way which most people do this question. Just like we said earlier, we can now equate the powers since our bases are both 2 on the right hand side and on the left hand side. So we can say 3x minus 3 is equal to 4. Then this 3 goes to the right hand side. We have 3x equal to 4 plus 3. 4 plus 3 gives us 7. So 3x is going to be 7. We divide both sides by 3 and x is equal to 7 over 3. So if you use this value of x and plug it there, you should have 16. It's always a good practice to test this. Since we have x minus 1 there, it's very important that we find 7 over 3 minus 1. A great thing that you could do here is multiply by the denominator here at the top and at the bottom like this. Then you have 7 minus 3 all over 3. This is not difficult to answer. This is 4 over 3. Next, this now will be our power since we've solved x minus 1. So we have 8, 4 to the power 3, and we now want to check if truly it will give us 16. We know how to treat fractional indices. This is the same as the third root of 8 to the power 4. Why I've decided to try to prove this is so that you know another additional property for indices. It's very difficult for you to find the third root of 8 to the power 4, but we already know the third root of 8. So what we can do here is this. We can get this 4 and work with it after we have found the third root of 8. Meaning we can do this. Isn't that much easy? It is, right? So we know this is 2, not so? So it will be a 2 to the power 4, which actually is what? 16, like we found. So we have found the correct value of x. With what we have covered so far in this video, you can answer most of the questions that involve indices. Now let's just try to solve some more questions involving indices just to get you comfortable with a variety of questions that are also examined. Here we've got a question that's asked us that is asking us to simplify. The key to such questions is you being very careful when dealing with the indices. So I'll show you how you can do that. Notice this is paper 2, so you could use your calculator. The simplification of this is not difficult. We have 42xyz over 56 multiplied by 32xy 40x squared y. Since we are multiplying these here, you could multiply them in advance. What I like showing people is you can work with these separately first before you multiply them. What can you simplify here? If you look, we have y in the denominator and y in the numerator. From laws of indices that we know, these two can cancel out. And because we have x in the numerator here and x squared, we can cancel this x and cancel one of these x's here, remaining just with an x. What that means is we have x1 minus 2. If we work this out, it will be x to the power negative 1. So since we are left with x to the power negative 1, we can convert this back to the original form, and hence why we will just be left with an x in the denominator. So with this, we can now perform our multiplication since we've simplified this part. Notice on this left part, we don't have much to simplify. So we'll multiply 32 by 42. We can use a calculator for that. So what we want to find is 42 multiplied by 32. Could do this mentally, but it's paper 2. You can just use your calculator. That gives us 1344, or as most people will say, it gives us 1344. So 1344, we have x, y, and z. And then we also multiply the denominators. We need 56 multiplied by 40. 56 multiplied by 40 gives us 2240, like most people would say, but that's 2240. So we copy 2240. Notice we have an x that comes with the 40. From this step we can see that the x and the x there will cancel, leaving us with this here. So you would leave your answer in these terms: 1344 yz over 2240. But in actual sense, you have a calculator, you could simplify that fraction if it is simply, since you have a calculator, you could go further than this. You could simplify this fraction using your calculator. So you go to your calculator, type this 1344, then you hit this button here, 2240, then hit equals. You can see that my calculator has given me the simplified form, which you would have also gotten if you did your hand calculations, but you are permitted to use a calculator in mathematics paper 2, so make sure you utilize it well. You look for the button just under this button here, whether you have this exact calculator or other versions. Yeah, you have the 3/5 in some way. So our final answer is 3yz over 5. We have simplified. These questions that we're attempting here are just utilizing our knowledge about indices. They're just simple questions. We'll answer this one also. We have a 99, m to the power 3, n to the power 2, 20, p to the power 2, q to the power 3, 33, m to the power 4, n, 40, p to the power 2, q to the power 3. This question is interesting. What I would like you to do in this type of scenario, remember I said we simplify the right part first and the left part first. Now if you check here, nothing is common, no? So we have m and n in our numerator, p and q in our denominator. When you have this scenario, check to see what sign is here. If you find that it's division, then what you need to do is convert this division to multiplication by doing this. Copy your left part, or the part on the left hand side of the division. These things have names in mathematics, but the names sometimes confuse people. Whenever you have this number, this is the number you are dividing, so it's usually called the dividend, what you're dividing, and then this number on the right hand is the divisor, what you're dividing by. So you get your divisor and flip it around, but most of the times just write division like this, and then what's on your right hand side of the division symbol is what you need to flip. Those names, it's good to know them. The most important thing is knowing the procedure. So after we do this, notice something. If we multiply this and that, this p will cancel with that. The q will cancel with that. Interesting, right? You can do the multiplication and then do the cancelling, but this is the easiest way. When they are separate, it's easier for you to see. Next, you look at this n and this n here. We have n squared. So from this n squared, remove 1. Remember, this is n minus 1. Since there's a relationship of division between this n and this n, you can see it gives us a positive n, meaning we will be left with an n in the numerator. For the m, it's a different scenario. We have m3 minus 4, which is m negative 1. The negative shows us we'll be left with an m in the denominator. So now I can write 99 multiplied by 40, which possibly you could put in brackets, and then in my numerator I have n, in my denominator I have 20 multiplied by 33, and I have an m that is left. Of course, you could cancel like that. And then what is left now is just me finding the final answer. I'll show you how to do this on a calculator directly, but I would prefer that you just go step by step. The first is you find 99 by 40, then find 20 by 33 and keep on simplifying just like that. So if we go step by step, I'll show you how to do it in one single step after we do it step by step. We first need to find 99 times 40. 99 times 40 gives us 3960. Those are numbers. Just go direct. 3960n. We do the same for our denominator. 20 times 33. This is a simple number. Whenever you have a 0 part of the number you're multiplying, you just need to put a 0 to your final answer. 33 times 20, we could have also done the same for the 99. 33 times 20 is the same as 33 times 2, which is 66, and then you put a 0. So we have 660 and m. Then we'll have to simplify this. You can simplify this using some hand calculations, but I'll show you how you can do it on a calculator. In case you don't trust yourself, you could have also done the 20 by 33. You can see it gives us the same answer. Now our job is finding 3960. Remember this pattern, 660, and there we have it. Our answer is 6. So our final answer is 6n over m. This is how you could do these questions very quickly. Some people will say, no, well, cooperating laziness, but you need to know how to use your calculator very well, because in later stages of your education, these simple things will make you very efficient. Before we end this video, it's very important that we deal with such questions because they emphasize something important about algebra, which are the order of operations. The order of operations, or what you know mostly as board mass, is very important. What do these mean? Board mass is the order in which you should carry out operations. First, you start with what's in the brackets, what is multiplied over there. Next, you follow division, multiplication, addition, then subtraction. In most of the cases, I've found that it's very important for you to observe the last 4 parts: division, addition, subtraction. In this question, that's what you need to focus on. So the brackets and over here simply mean you need to do what's in brackets first. But most of the times, the most tricky questions about order of operations or about board mass are those where you don't have brackets, like this one. If you mess up which operation you do first, the whole question is wrong. One thing you can just do here is check. From board mass, can we do division before multiplication? Of course, that's a check. Meaning we can't get this to 24a over 15 and multiply it, then divide. Our correct approach is treat the part with division first. Now, the trick again is, if you have multiple divisions in your expression, how do you continue with BODMAS? Well, the easiest way that I can show you is, whenever you have a division, perform the trick that we used earlier. Change the division to multiplication everywhere in your expression, and then you will get the question most of the times correct. So we have multiplication. How undertake this question is, first write my first part. This division, convert it to multiplication, meaning I'll flip that part, which is on the right hand side of the division symbol. Just you locating the divisor is very important. And then you can see the question is very much easy to solve now. We have multiplication everywhere. Now, we at this stage can now just start cancelling what is not necessary. So, if you look here, we have AB, AD, AB and A, AD and AB. So we've got A's in the numerator, A's in the denominator. Since this is a very long series of multiplication, I would encourage you to just put these numbers together and then get this A multiplied together with this other A. So A squared multiplied by A, it's A to the power 3 multiplied by A squared. Simply you just add the powers here. The 2 plus the 1 and the 2 gives us A to the power 5. Then B, and that B gives us a power of 4. We only have D to the power 3 in the numerator. Next, you do the same for the denominator. In this case, because we have a series of repeated letters, this is the best way we could handle such a question. So there are kind of 3 ways for you handling this, and we've covered them in this video. If you haven't noticed them, just rewind a bit to the other questions. You will see how we have treated them. 3 plus 1 plus 3 gives us 7. 3 plus 3 is 6, plus 1, 7. Then we have a B, just a single B. A D, which has an index of 2. You notice in this question, this will be the better way of doing it. Rather than trying to cancel a lot, you might get lost because we have A's here, we have A's here. In the other question, it was just an issue of focusing on 2 parts. With this done, now let's focus on our variables. Which ones are disappearing, which ones are going to remain? You can see we have A to the power 5 and A to the power 7. That's the same as A 5 minus 7, which is A to the power negative 2, showing that we'll have A to the power 2 remaining in the denominator. This A is going to go, and this here is going to become a 2. For the B, we have B to the power 4 minus 1, giving us B to the power 3, meaning B at the top will remain with the power of 3, whilst the B at the bottom will disappear. For the last one, we have D 3 minus 2, giving us D, which means the D at the bottom will disappear, and we'll be left with D to the power 1. Next, what you have to do is simplify these numbers. I've shown you the quickest way you could do that with a calculator. In most cases, you can find a way to do this by hand. For example, 15 into 15 is 1, 15 into 30 is 2. From here, you could divide the other numbers by 2 and things like that. I can get rid of this 2 here by saying 2 into 2, 1, and 2 into 18, I have 9. You can see I can keep on doing this. I can now see 3 can go into 9 and 3 can go into 24. 3 into 9 is 3. 3 into 24 is 8. And you can keep on going like that until you find your final answer. But here I am okay with what I have here. I can simplify that remaining part with a calculator. But if you need to simplify by hand, that's the way you could go. You keep reducing until you have your reduced form. So right now I have in my numerator 18 and a 3, which is 54. So I can say 54, and then in my denominator I have 16 by 8. So my simplified version here is 27 over 64, which would have been the next step in this problem. So you can see even by hand calculations I would have gotten this answer. Next, we can also try to see if we would have had the same answer if we just went direct. 18 times 3 multiplied by 15 multiplied by 18. Then in our denominator we have 16 by 24 by 30. You can see it gives us the same. So you are now sure that whether you use hand calculations or use the calculator, you will still have the same answer. It's just that using a calculator will give you the answer much more quicker. So we have a b to the power 3 and a d. In our denominator we have 64 we have a raised to the power 2. I'm sure most of you will be asking yourself, how can this calculation come to 27 over 64? It's simple. If you divide 18 by 2 and this 8 by 2, you easily come to 9 times 3, which is 27, and 16 times 4, which is 64. So it's the same thing by hand or by calculator. This marks the end of this video about indices. You can see they're a very important topic in algebra. If you don't know them, you will be missing out of some marks from your final exam. Next is going to be part 3, which you're supposed to watch out for, which will talk about the final things that you're supposed to learn about algebra. Make sure to have watched part 1 so that you can build up and prepare for your exam properly.